So welcome back, everybody. Again, Louis Martin Vega, Dean of Engineering at NC State. Just honored to be the moderator of this last session. We have two more presenters in this session, and then we are going to go into a discussion mode. So let me just move right on with it. I'm delighted to present our next speaker, Dr. Alice Agagino. And Alice, I have many, many things under your name here, and I'm going to share some of them for sure, right? Alice is the Chief Executive Officer and co-founder of Squishy Robotics. She's also the Roscoe and Elizabeth Hughes Professor of Mechanical Engineering Emeritus, affiliated faculty with the Energy Resources Group, Women and Gender Studies, Development Engineering, and Studies in Science, Engineering, and Math Education departments. All of these at the University of California, Berkeley. Professor Agogino, Alice, delighted to see you again. Wonderful to have you here. Let me just turn this over to you, okay?
Okay, thank you, Louis. It's so great to see you, as well as eminent colleagues of mine that have already spoken today. It's a memory lane, actually, of people that have been so innovative in engineering education. So I thought I'd follow a narrative arc that shows the impact and interconnectedness of enabling NSF grants with me over time. Do you see my slides? Hello? Do people see?
Yes, I think we can see. We can see them. They've come up well. Yeah.
Okay, I just want to make sure. You never know. I get
absolutely.
And nobody's seen anything. Actually, when I started at UC Berkeley, I was the fourth woman hired, and 3 women had gone and left for various reasons and never granted tenure, or they left because they were unhappy. And so it was a challenge because there had not been any women tenured in my department. And somehow I got the impression that I would never get tenured either, but I was going to make the most of it. And so it was really exciting my first year to win an NSF Presidential Investigator Award, because that really laid the foundation for other things that I could do at UC Berkeley, including starting the first integrated AI hardware lab that had ever been developed on campus. This Presidential Investigator Award led to some open source software that I developed that you may remember, the concept database, using mass customization, and it became the patent buster for database-driven internet commerce, as this prior work broke the existing patent, which came 10 years after my prior work in this area. So we should all thank NSF for funding me and my students, for why you don't have to pay a license for selling something or buying something on the web that is configured through a database, which is just about everything in the world these days. This grant led to other applications of database-driven multimedia design research and translation to education and practice. And this work also came to the attention of Tony Ingrafia at Cornell University, who is forming a coalition to respond to a new high-impact RFP at NSF. We won the grant. The NSF-funded Synthesis Coalition was a union of 8 diverse institutions, you see their logos here, funded by NSF to design, implement, and assess new approaches to undergraduate engineering education. We emphasize multidisciplinary synthesis, teamwork, and communication. We worked on hands-on and design prototyping and laboratory experiences. We developed open-ended problem formulation and solving curricula, and we created examples of best practices from industry through multimedia case studies. And we worked hard on inclusive and diversifying practices. The coalitions were transformational in revitalizing engineering education for the future, and many of the speakers yesterday and today have participated in those coalitions, and I'm glad to see old friends here. They also provided the foundation for some of the innovations in the National Academy's volume, The Engineer of 2020, and educating the engineers of 2020. Although it's past 2020 now, it laid the foundation for innovation for the future. So I will summarize some of the highlights of this program. The multimedia case studies of engineering design included looking at design in a broader sense, and included industrial design, design for assembly, design for manufacture, custom-driven design, and design trade-offs, design for the environment, for ergonomics, and included social implications of design and the history of technology. And these multimedia case studies were used both for K through 12 outreach as well for integration to all levels of engineering, freshman design and senior design classes. And Sherry Shepard, who will be speaking later on today, took the lead on artifact dissection case studies in which she worked on hands-on learning and taking things apart and understanding the big holistic picture of what went behind the design and the manufacturing of that product. I was also very interested in increasing the diversity in design. In particular, this is one example where we had a problem of gender differences in spatial reasoning that was really hurting the advancement of up-and-coming female students that were joining the engineering program. I worked with a team to co-develop spatial reasoning software using a natural environment for engineering graphic students to improve their spatial reasoning and 3D visualization. I worked with Marcia Lynn in our Graduate School of Education, and we focused on authentic evidence-based assessment, and authentic in the sense of skills that are needed in engineering. Evidence-based assessment to remove any gender differences in spatial reasoning, and we succeeded in these goals. After our interventions, there were absolutely no differences, statistical differences by gender in spatial reasoning skills, and everybody's skills increased greatly. This work provided the foundation in several amazing textbooks, one by Dennis Liu and another by Cheryl Sorby. Courseware and digital libraries emerged from this grant as well. What you see here is the engineering pathway on the go. The idea is you could take your digital library with you. How would you use it in a location-sensitive learning resource? And in this case, imagine you're staying at the Claremont Hotel where this was filmed, and you want an educational experience with your family that's there, associated with UC Berkeley. And you see the UC Botanical Garden is just down the road there based on this digital library, pulling up the information from our database. The Premier Award was developed and given out annually for over a decade with the goal of raising the bar on the quality of the pedagogy, content, and multimedia of emerging technologies associated with courseware. And you see some examples of that courseware here. Diversity, equity, inclusion, and community-based design were critical elements as well in synthesis. I later won a Distinguished Teaching Scholar Award to support integrated teaching scholarship with a theme called Designing for Diversity. And the idea is if we change the content and the projects we worked on and the communities we worked with, could we change the diversity of the students that attended those courses? So I launched courses on Designing for Diversity, working with communities such as Girls Inc., low-income migrant worker communities, and Native American tribes. These courses did draw on a diverse range of students. For instance, the Designing Technology for Girls and Women was 100% female. And I interviewed some of the male students and asked what their interest in the course was. And they said, shouldn't everybody know how to design for girls and women? Other faculty were also engaged in different forms of non-traditional engineering. They were engaged in community-based applied research, but they weren't necessarily feeling that they were part of a community in their home-based department. So we decided to redefine engineering on our own terms. And we started the development engineering program. It started out as a graduate group and a PhD minor, hosted at the Blum Center for Developing Economies. Later, we won an NSF research traineeship grant to launch the NRT Infused STEM Training for Actionable Research and Global Impact. And our focus was on food, energy, and water systems. And you see an example of one of our projects here. But based on student and industry demand, we launched a 3-semester professional master's degree program in development engineering as well. And in fact, we are just welcoming our second cohort to the program. Our vision is to educate change makers and foster innovative solutions to global problems. And to fulfill this vision, we want to empower students with the ability to develop scalable and sustainable approaches to complex societal changes, both globally and locally. We want to educate those graduates to design sustainable solutions through technology innovations and social entrepreneurship. And we want to enable them to contribute to developing a more sustainable, just, and equitable world. And one of the highlights, I think, of the work that we've done in development engineering is our new alliance with Native Food, Energy, Water Systems. It's focused on innovative research and community partnerships, linking and addressing two interconnected challenges: a crisis in access to food, energy, and water in Indigenous communities, and limited educational and career pathways that are available to Indigenous populations to address these needs. And we're very honored to have ACES, where our last speaker came from, as part of a co-PI for this grant. So I'd like to end with the note that you started with, and that was squishy robotics, because NSF has funded a number of impactful programs that translate research to practice. Squishy robotics is actually a spin-off of my work with NASA on planetary probes for space exploration. We designed probes that could circle a planet or be shot out of a secondary rover, survive the impact, and walk away and do scientific monitoring, as you see in some of the pictures here. And through an I-Corps grant, where we learned how to find customers that would actually buy our product, we started with first responders for hazmat response. We won a phase 1, phase 2 NSF grant, and we're working on the phase 3 with contract funding. We incorporated and provided customized sensing solutions, a platform for third-party delivery, monitoring and data, and we also provide monitoring and data as a service more broadly. When every second counts is our motto. We want rapid delivery, would provide information when we need it and where we could get it. So the spin-off with NASA provides us life-saving, cost-saving information in real time through rapidly deployable robots. What we got is some great press. We just captured the imagination, not only of our customers, for the world. And this is just an example of the magazine Popular Mechanics, where they wrote an article about the squishy robots that could save the world. You can't be press like that. And through the I-Corps program and the various SBIR programs, we were able to incorporate, and when every second counts, our sensor robots can be rapidly deployed by aerial vehicles. And we've tested them 400 feet from a helicopter, 300 feet from a drone, as you can see here, and 1,000 feet, 300 meters from fixed-wing aircraft. They can survive the landing and continue to provide time-critical data to first responders. We're doing right now, we're working with hazardous material, emergency detection, and working with first responders. But we are moving into early detection and prevention of wildfires and methane leaks because of the critical emergency in those areas right now. So part of this program is looking at how do you communicate your technology to the world. And we've been quite successful in earned media, which has greatly helped us in our customer development. But we had to think about different forms of communication, such as trade journals, popular journals, as well as some of the professional journals that we participate with. So I'd like to end by saying thanks to the extraordinarily impactful students I've had the pleasure to work with, and you see some of them here. And I want to recognize NSF's innovative funding support, and I've tried to put the grant numbers to each of the steps along my pathways to getting here. So thank you for attention, and I look forward to a discussion.
Alice, thank you. Thank you very, very much. And, you've sort of, in a very concise way, really shared a really, really phenomenal journey, right? And, you mentioned it. Say again?
And it's interconnected, different NSF programs interconnecting in a holistic way, which is the beauty of NSF.
Yeah, so I was just going to ask you as a little follow-up, you mentioned that you were the 4th women faculty member hired at Berkeley and 3 had not been successful. And was it the NSF grants? Is that what you said that really started the momentum that allowed you to move forward? Is that correct?
Absolutely. I wanted my first year to help out. That made a big difference. And it just changed the expectations. There was actually, when I was elected to the National Academy of Engineering, my department had a little party for me, and maybe a little too much champagne was flowing. And I asked one of the older professors, he congratulated me, and he said, I remember that faculty vote we had about whether women could actually become engineering professors.
Is that right?
And I metaphorically fell on the ground. I couldn't believe there was actually a vote. And I asked him, what was the vote? And he said, well, it was close to 50-50. And I did a rough calculation about the age of my colleagues and how many would have been in that room during that vote. But the NSF awards are just so prestigious. Mm-hmm. No matter what you do, they enable you to create the technology that can make advances. But I think they are also viewed in a way of pathway to success.
Well, I again, here we are talking about, the extraordinary impacts of engineering and how much of that is facilitated through NSF support. But the most important thing are your stories, Alice, like you say, right? And this is very personal to you, I know, right? So thank you very much. Thank you. So you'll be able to stay with us in our discussion because we want to follow up on a few things there. Is that okay?
Would love to. Thank you.
Sure thing.